Okay, we are back with a new stream, new week, new day, all sorts of lovely things. I hope folks this Monday are going well. I know Mondays can be tough, but we're near the end of the year, so it's time for the holiday season. Lots of good stuff. I am waiting a little bit longer for anyone else stuck on an ad break, making sure we're good to go. But this will be more of a how do you design a database when you've been given a CSV that you're like, we chose to do this? Oh, okay. This is actually based off of something that I really did have happen to me. So I figured it might be fun to show you what it could be like. Not everything is prim and proper and pretty and planned out, or sometimes they are planned and then they didn't accommodate like how much. So I'm being abstract on purpose because I can't really talk about it, but I've adapted my experiences to this workshop. So yeah, at this point, people should be done with ads. But good news is I'm finally working on the sweater that I put aside for months. It was supposed to be a Christmas gift last year. So we're trying really hard to finish it before Christmas this year. Okay, I finished half my rows, therefore I can focus on coding. So this is how I deal with ad breaks. Okay, so if you have never been to one of my streams, welcome. We make lots of mistakes and have lots of bugs, but that's okay. Specifically, though, I try to make sure that what I can teach, I do teach. And if there's things that I don't know, I'll sometimes ask chat, be like, what do I do with this? Or I don't know what I'm doing. Because it does happen where I'm just like, I have Googled, I have followed a tutorial. I still don't understand because I didn't have time, but maybe you might. And so I welcome you to chime in when you think you know something, or you're like, why didn't you use this library instead? And it's probably because I didn't know it existed. Mostly because I've been doing a PhD for a very long time, but it wasn't in engineering. It was not programming focused, so I fell out of practice. Conceptually, though, we're good. So, all right. So you want to be a database expert. More specifically, you want to move on from SQLite. You've always used it for your prototyping, and if you're not using it for your prototyping, consider it. SQLite is pretty friendly as far, it's like the Python of databases, if you will. Super easy to just get started, spin it up, have local instances. No need to download much, which is why it's SQLite. But as you get into the workforce, as you go into industry, you'll find that people are very much not using SQLite at all. They're using things like Mongo sometimes, but more often you'll find that they're using Microsoft SQL, a database, or PostgreSQL. And so PostgreSQL is what I ended up using, and that was how I first learned databases, not even SQLite, because I was given CSVs that were complex that needed to be processed and put into a database. The way their data pipeline worked is just that CSVs were generated. There was no direct like upload to database. And so there was that middleware, like that pipeline step that we had to come up with. So as for what is Postgres, it's just another SQL database. If you checked out Jocelyn's MongoDB stream, you learned about unstructured databases that were more document focused. And if you checked out my sticker-based stream, we were also using Mongo. And I picked that because it was so flexible with the schema. PostgreSQL, SQLite, well, maybe not so much SQLite, but like Microsoft SQL, databases require a lot of planning. And especially when they're going to be structured, it means you need to have a pretty clear idea of what you're expecting, what's going to happen each and every single time. The moment you start having to make edits, it is a whole day-long affair at production level. And so, again, transforming into professional industry, you might consider using PostgreSQL. I find it very friendly and easy to get started. You don't need to have a Windows machine to use Microsoft SQL because we're using Postgres. And there's some, in my opinion, some kind of nice things that come with PostgreSQL called pgadmin, which lets you interact with the database on a visual level instead of just having to do it through a command line prompt, which you can, and I would recommend just in case, but there's more typos and stuff. So as far as SQL similarities, it's almost exactly the same. There's just some tiny keyword differences, but the functionalities are very, very close. And so in the interest of, following the pipeline that I ended up doing when I was at that employment or doing that project, I did it with Python, where I was using Python to process the CSVs because I thought it was the fastest to write. And then using scopg, which is like for me, it was a document writer and it was just easy to process and like go write stuff. My limited understanding is it might be like an ORM library-ish, but the point is if you have to process data on a file level, scopg is your friend, especially when you're putting it into PostgreSQL because it is a library associated with that. So that's kind of a brief overview. Like I said, Python, PostgreSQL, not much more than that really. And we're going to introduce some constraints on purpose because I know there are other libraries out there to process CSVs like this, but I really want you to get your hands dirty with messing with the data in the spirit of, the fact that it's, data month or data week. Because I really want to make sure that like, if you were given this inopportune, this very, very unstructured problem, that you'd be able to solve something like this instead of being like, I can't do it the way like other people do it because it's not perfect. You won't always get perfect things. You'll be introduced to new problems. So that's why this workshop exists. And it is meant to be only just the one instance in this series, with the goal being that even if we don't get it right into the database, we at least have processed the data in a way that makes sense to us, that we could then go on and, get it working. And I'm pretty sure we're going to have bugs because that's just how it is. So if you haven't checked in already, go right ahead and do so, because I'm going to go ahead and take right to get that banner off. Let me know if you want that in chat. But let's take a look at our data. So this is not actually real data. I had to take what I knew from the data that I was working with and make a similar example that was not going to get me in trouble. So welcome to our data. It is the family relations CSV, where right off the bat, you're seeing, hey, there's a lot of like repeated information here. We have first name, last name, age, but then it repeats, but now we have the additional column of family relation. And as we can see, there's, a couple different variations where sometimes there are no more family members, or there's just none that are listed. So let's imagine in our head, someone is filling out a family tree of sorts. I did not like sanity check this to be like, yes, this person has a variety of family members that don't make sense. I didn't sanity check it. I just wanted a proof of concept, this type of CSV. But you'll notice the first row, the columns end, but the next row, there's a few extras where there are at least one extra, but it follows the same structure. And so this is something I did run into where they're like, yeah, the first row determines the headers that appear, but there's a chance that in future rows, you might have less or more than the column headers that appear. You'll have the same base structure, but you probably aren't going to have all the headers up here. So right off the bat, that knocks off some like keyword-based processing where it's like, oh, pick column, take data, move on. We've completely lost that ability unless we want to manipulate the data. Not so fun. So now we have to figure out a new way to do this. So thinking ahead of the programming, it's like, oh, that's gross. But okay, you chose to do it this way, which, to each their own. But yeah, when I saw that, I was like, you want me to what? You just don't have, and they're like, no, why would we generate more than we have to on the first row when it's repeating? And I'm like, okay, like, I guess I get it. We can see there's like a number of people here, of course. And then again, like I said, there's people who have no mentioned family members, and there's some people who have a few, and so on. So very basic example. I will say the data that I worked with was far more complex than this, had so much more to it. I just wanted to get the basic gist being that we have an irregular CSV, but the structure will maintain some similarity. To show you a little bit more about the complexity that I had to deal with, I actually had a few extra lines at the beginning of every CSV that I received, or Excel sheet, or whatever it is. I think I was working with Excel, actually, so I'm being nice and giving you a CSV. Excel is disgusting to process. Very annoying. But with the first few lines, it would tell me more about the file. So it'd be file metadata, which normally I can get programmatically, but it would give me extra information like, hey, which column headers are going to appear and which won't. So I had a hexadecimal code to tell me this column, this column, this column, but not this column and not this column, but this one, this one, this one. And that would have to be how I confirmed, was this file corrupted? So I could go through and check the headers on that first row and be like, does it match? Yes? Okay, great. Let's process it. If it doesn't match, then something went horribly wrong somehow, and that needs to be kicked off to a human to deal with. So terribly complex. We are doing a modified, simplified version, again, because I was like, we don't have to do it that way. For their purposes, actually very efficient, very much necessary why they did it. But I just, first time it's like, what? You want me? You what? You designed the file like what? There's a lot of questions. I had so many questions. I think most of my mornings when I would come into work would be like, hey, before you get caught in meetings, let's talk about your spreadsheet. Okay. So we're taking a look at our CSV. I gave you the cheat sheet of like not having to process as much of it. But let's go ahead and put this in this window. And then let's go ahead and start understanding the data enough so that way we can make a schema. So prefacing here that when I first did this, I had no idea how to make a schema. I'd never worked with databases before. I was brand new. I was like, well, I'll process the like CSV or the Excel sheet and I'll look for the patterns and understand what's going on. And then I was going to prepare a schema for them. Before I ever wrote it to a database, I had to prove to them like why the schema works, what I was doing, considering the relationship. So I did have a little bit of help with that, but they were also like, honestly though, you're the only database person on our team right now. And I'm like, oh, okay, great. I arguably though, because of the way I deal with data now, this has been a formative experience. It just is not how I would recommend teaching someone this, unless of course, like you prefer a more hands-on approach, you're very self-directed, in which case this is perfect for you, which it was for me. So, okay, coming back to this, we have our headers. We know that we're going to have some consistent data where we start off with our first set of information. We have a first name, a last name, and an age. And we know this is a family relations file. And let's say we might get a bunch of files, like tons and tons and tons of files that have similar structures where maybe it's like we're a medical group or something and we're collecting family relationships or something, or there's a research, whatever it is. And each session needs to be isolated. And we have to make sure that we collect the information and maintain it in a way that makes sense. So the wrong way to approach this is be like, well, everybody has the same information, first name, last name, age. Let's just put everyone into the same table and then like assign a relation. It's like just keep the relationship as an optional field. And so if we go to our database design, let me go ahead and delete that. Can I comment? Yeah, we're going to save that because I don't know how to use diagram designer like this. I used a different one. Come on, slash. Okay. So we're going to have a people table or humans. I think it's funny to call it humans. So we have an ID, which wouldn't hurt. And then let's do first name, last name, and age, which is going to be a number, I think, integer. Let's do unsigned integer. Can I do unsigned? Interesting. Interesting. Cute. Sorry, I really haven't used this DB diagram types. What types are allowed? Documentation. I just want to see what their types are because we'll need that later. Fields. Oh, int, I guess. I prefer to, okay, whatever. It's fine. All right, so we have something that incorporates the first name, last name, age, and we have an ID because we want to make sure that every name we get is unique because there's a chance that we might get a repeat of a name, which would set them apart, even though it's like, well, if they already exist, that'd be really awkward if they're a completely separate person, such as John Doe. I'm sure there's quite a few John Does out there, especially if someone wants to give someone a false name. So we have our humans table. And a naive approach might be like, well, let's just go dump all this in and make them also humans because technically they're also humans. But the more we look at our data, there's obviously this family relation column. And so now we need to figure out how to link it back to very specific humans and their family relations. So we can't just dump them in willy-nilly. And so because of that, we'll need like a secondary humans page or a related humans table. And so we'll do something like that. So we'll copy table this and make related humans. And technically table, okay. So technically you should be using capital letters for your tables. And everything else is going to be camel title, whatever it is you prefer to do. So types are important. SQLite for a little bit, I think you could kind of be a little flexible with your types. I prefer to use types that are as restricted and space conservative as possible because an integer is going to be a 64-bit number. And I don't know about you, but grandma ain't going to be, a couple million years old. We don't want to do that. So we might choose a smaller one if that's available. And so that would be something like a short. Let's see if it'll let me do it. Yeah. So short would be a better one to use for age because, grandma still can't be, 256 years old. But we now take up less space in our database. And, with the wonders of cloud and everything that's been going on, we don't really have to, I guess, worry as much about space. But back in the day, space conservation was extremely important. And if you have any familiarity with hardware, you know that space conservation is still very important. Memory allocation is critical. And so the way that you initialize things, the way that you set up your information, and I guess a more applicable thing for today, the amount of storage you pay for, even though they're like, oh, cloud, you can have up to 1 gigabyte for free. Well, that adds up, especially if you're doing a giant research project across the entirety of the United States or across the whole world. And all that data adds up. So choosing things that make the most sense for the size that you're expecting or hope to expect, but being mindful that there might be things that are maybe someone's first name or last name is extremely long. So in the case of last name, you wouldn't say like arbitrarily, oh, the limit's going to be 20 letters. Well, I will give you the example of the US Social Security process that if your name is too long, they'll just chop it off because they don't have room, which makes for weird validation and legal purposes, and that's a whole other thing. So people will have to like modify their name to meet those constraints that weren't really friendly to them in the first place. So be mindful in setting restrictions of where it's appropriate. So now that we're starting to think about beyond the usual, like, well, I'll just make it, 20 characters. Don't think about it. Make sure you think about it before you do it. We know that there will be a specific type of relationship, which is that you could have multiple family relations or related humans, but you could also have no related humans, and you could also have one related humans. So in this instance, we are now looking at a one-to-many relationship, where you would say it's a 0-to-many. And that's something we don't really have to worry about too much. It's just making sure that the IDs link back. But we also want to make sure that in our related humans, whenever we have our foreign key, which I deleted that and how they did it. Let's go see that really quick. How did foreign key look like? One moment. I just want to see. Is there no... Oh. I think it's... Okay, I see now. This is such an interesting little diagramming space. I've not used this. I think I have used it, but not like this. It was a very long time ago. So in related humans, we're also going to have a humans foreign key, and that will be of type integer. And we'll need to link this back where that will be humans.id. Not follows. Whoops, a daisy. Humans FK. Don't mind me just learning this thing on the fly. Okay. Yes. So, as you can see now, we've drawn the connection where there will be one ID to many possible humans. Interesting. Oh, my desktop is still flickering. Okay, good to know. I just need to last one more stream. Just one more. Just one more. Anyway, so we have a foreign key, and the foreign key's job is to link back to wherever this appears on the humans table. So we now have an idea of what our relationship will look like. Yay. But what else might we stop with the ads, please? I don't want ads. I just wanted to show what this looks like. It's not that hard. Okay. Where were we? We were designing the database. We have an idea of what this looks like. We also are forgetting one last thing, which is something that I added last minute, which is we need file information or perhaps source information. We'll call it file for now. And let's actually call it files. And I'm using a pluralized title because, of course, I will have a table that consists of many humans. If I were to just put human, then the expectation is maybe that I would only have one row. It's just prettier to read. Go with me on this. So our file will have information like the file name, and that will be some character name. Then we're going to have, of course, our ID, integer, primary key. There's a lot of different ways to do primary keys. Some people use UUIDs, which is a very good idea. Some people will just manually count one upward, which kind of sucks if you have to delete things or edit your database in some way. Try not to do that too much. UUIDs are better in my opinion. A little more secure as well. File name. Let's call it date collected. Make that a date time. If I can spell. What else might we need for that file name? Yes, we need to also have the foreign key, which is the file foreign key. That will be of integer, and that will link back to our files. Okay. Alrighty. Let's zoom out a little bit. Related humans goes here. Why are you doing this way? This is not fun to read. Okay, fine. Point is you'll still have another one-to-many instances of humans per file. Okay, so we have a gist of a schema, which coming back to our original problem statement or idea or concept that we're going with is that we are doing a research study. We're collecting familiar relations. It means that each session will generate a file. We only have one file right now to work with, but this will give us an expected structure of where we will collect the human itself who is giving us their family relations, and they will give us a 0 to many related family members with the specific relation itself. So something that we're missing in the related humans is actually the relation attribute. And there we go. So now we have an actual way to understand, well, what if we want to know how many people have grandparents or how many people have siblings? Maybe they're looking for how many people don't have any family to mention at all. And so that might be something we look at. And so now that we have an idea of what our schema looks like visually, we could actually go ahead and use pgadmin and develop this database, or we can go ahead and we can start processing that CSV. So let's pretend we already talked to our boss. Our boss is like, this is a good enough schema. I wish you could, space optimize it. And then of course we might switch to using short for certain values, like age here should be short. And limiting the relation to a specific enum of values or something. But then of course, what if there's a family relation that someone considers that are we considering biological family relations or social relations? Because then you have godparents and a variety of other things. So you'll need to determine that and ask about that when you might present this work and say, are all these people who are, mentioning, are they biologically related only? Are they socially related? At which point your boss might be like, I don't know. In which case you're like, great. If this is a medical study, we're screwed because we didn't ask that question. Anyway, so we have our references. We have this. Great. Coming back to our checklist, we have made our schema. So before we actually write the CSV, we need to make sure that we process said CSV. So we're going to work with objects first before we start integrating psychopg, just to prove that before we write anything to our database that we know what content we are writing. So using objects in Python is a great way to make sure that you're doing this quote unquote right. And also like debugging is easier, testing is easier. It might be easier to separate functions that way, that when you're ready, the data is already structured and you can just write all at once, and it's just a dump into the database. But coming back to this diagram, you saw that we had these foreign keys. So in order for any of these things to exist between humans and related humans, the file needs to exist. So when we're doing our write to our database, we can't write a human with a foreign key that doesn't exist, especially if we don't have it. And this is where the difference between generating something might be important, but then you might have some discrepancies in IDs, or upload the row data, get the ID, and then use that ID excuse me, to write to your other databases or your other tables. And so this is where you start considering, like, again, time space complexity. What are you thinking about, and why are you making this choice, and can you justify it? And this is pretty critical, especially when you're working with sensitive data or potentially sensitive data, that you really want to make sure that you've done due diligence. So let's go ahead and open up Visual Studio Code. I've already done some setup, which was that I set up a virtual environment and that I pip installed Postgres, the psychopg library, which there's a little bit of some nuance here. But in order to, excuse me, I didn't sleep enough last night. I was up debugging. Installing quotation mark psychopg, bracket binary close bracket close quotation, that is what you will be installing to get the psychopg library. Now, if you decide to Google this, there will be two libraries that will be available to you. There's psychopg version 2 and psychopg version 3. And of course, version 3 is the newest, so I would recommend you use that. But way back when I was doing this stuff, I used psychopg 2. So there might be some things that I use that might be out of date because I don't know the difference, because it's been a while. It's been over 5 years since I worked with psychopg, just because I haven't had to do database work in a very long time. Much less like this, where I've had to start up everything and write stuff in a document writer instead of just like API request, send. So yeah. How are we doing? Oh, we're like blazing too. Oh, goodness. Sorry about that, folks. If I drank coffee, maybe that would, solve it, but I don't even like coffee, so, oh well. Anyway, so I know the moment I start processing this CSV, you're all gonna yell at me. As you're gonna say, why don't you use pandas? Why aren't you using this? Why aren't you using that? And at the time, my boss said, we don't want to use pandas. We don't want to use NumPy. We don't want to use any of those libraries. They haven't been tested. And I'm like, well, shit, okay. I guess I'll just do this from scratch then. And so I had to, because again, I was working in Excel. I'm being nice. We are not working in Excel. Excel is a whole other battlefield. We're just going to use import CSV. Simply because I'm like, we have 2 hours for a stream. And I don't want to get into the world of Excel because Excel sucks, at least when you're processing it from a code standpoint. It will not, because I don't want it to. I want it done by the end of this year. But I'm going to go ahead and import CSV. As for what kind of job it was, I mean, I had to do tools for the tools team, basically. I really enjoyed that job, though. I had really good coworkers. They're the reason that I continued in state and coding, because I was very intimidated. And they're like, us too. I'm like, oh, that actually is pretty nice. Okay, so virtual environment. If you don't know how to do that, let me know, and I will very quickly do that. But otherwise, I'm assuming you know. And then hopefully once you have the virtual environment set up, you've already installed psychopg by using that binary. And again, we're not going to use it just yet, which is why I have it commented out. I've just named my file db.py because I'm lazy. It should be something like process, family relations files or something, and maybe that you pass in a pathway to the file itself, or that you do something manual. We're going to do something manual for this instance, but there are other ways to optimize this using like arguments and other ways that you might want to call this script, especially if this script is going to eventually be put in a pipeline, which in the real world example that this is based off of, this work was put in a I believe a RabbitMQ task pipeline, where anytime a file was uploaded, it would go through this file, and then this file would also handle the writing to the document, to the database. And the person who helped me with this was like, by the way, you need to write tests. I'm like, no, I don't want to write tests. And he's like, too bad. You have to write tests. I'm like, okay. So the lovely thing about this kind of approach is that you can also write tests. So it's good to break stuff into functions so you can test individual things instead of, black boxing it and hoping for the best. Yeah, so we're going to import CSV, and we're going to go ahead and open our file. So with open file path mode, we're going to read the file. We are not editing things. There's going to be new line is equal to blank, and it's also going to be default encoding of UTF-8. There should be no special characters. However, what if you have accents? What if you have other things going on? And this is something to consider depending on where your stuff is scoped. For example, if you are working around the world with this, you might want to use a different UTF encoding, especially if you're working with folks that have characters in their name instead of letters. Chew on that for a bit. S file, and Copilot is already giving me some stuff. So we're actually going to very manually build this up, where we're going to say, well, yes, go ahead and read it. And you'll notice that what I'm missing here is that file path, because I didn't clarify that. So our file path is actually going to be super lame, and it's going to be operations.csv. And let me go add that file. I actually already have this. Let me go move this in. What did I name this folder again? DB relations. Okay, we now have access to familyrelations.csv. Cool. And now we just see if it compiles, which, hooray, it does. Rainbow CSV. Cute. I didn't have that back in the day, so we're not going to use it. Yeah. So this is giving us our headers. Great. It's giving us our rows right off the bat. Great. That's cute that it's giving us all of these little empty quotations. So I'm going to go delete those, because what if we didn't get those, I'm just messing with the system on purpose. I'm going to make this harder on purpose. Because again, I worked with Excel, so I didn't have cute little commas to tell me it was the end of the row or that there was missing data. All right. Some minor changes just to, make this real. But now we have our rows. We know that we're going to have to skip the first row because that's our headers. Now, again, testing purposes related, or wanting to make sure that we're doing this as accurately and as reliably as possible. If we knew that the header structure would always be the same, that the first 3 columns would be first name, last name, age, and then there would be an indeterminate amount of times that the next 4 columns will repeat, then we would want to make sure that there's no file corruption in the headers, where we would check, first name, last name, age, relation, first name, last name, age, relation, first, and keep going and making sure that those headers are accurate. We're not going to do that, but that's something to consider as far as, again, making sure your file's not corrupted, because that would be something that would go so far. No questions so far, but then again, this is somewhat straightforward so far. And so let's see. So we've already done our print row. I did make those changes to the CSV. Let's just make sure it didn't propagate. Great. We now have in a supposedly clean approach. So with CSVs and the way Python works, now we have our row. So what if we wanted to get those first three columns? Because again, we know that will be the same each and every time. So now we have first name is going to be equal to our row at column 0. And our last name is going to be our, wow, this is actually super nice, except, heyo, it goofed. We don't want relation, we want age. So again, thinking about this from the reliability standpoint, what if there's spaces? What if we, have weird stuff going on? So let's go ahead and add a dot strip to it, which should remove leading and ending white space. And this is important just in case someone happened to fumble finger and add spaces to the end to their entries. And let's say there's no guarantee that we'll be getting the ages as numbers. And so sometimes we might, sometimes we won't. But as you can see from the CSV, it is consistently a string because we printed it out and we're like, hey, that's a string. So we need to also go ahead and convert that. But what if somebody, for whatever reason, when they made the form, did not do any form of, what's it called? Validation, where people can add letters in. So we also want to make sure then that after we've stripped things, we want to convert things to an integer. But with Python, whenever we're converting to an integer, we want to confirm, is it even a number in the first place? And if not, how do we handle that? Do we want to just fully break the script and let it crash? Or do we want to safely exit or safely put, a none, a null, or something else to indicate that there was something wrong with that entry? So safe failures, if you will, that it will continue to process even if people have decided to goof. You've jinxed me. There will be bugs. Please hold. All we're doing is processing. There's a chance there will be bugs, and there is a chance there will be bugs when we do the database stuff anyway. So I fully expect there to be bugs later. But it's tame for now because it's easy. But I have to say, I think it took me, it took me 2 weeks to generate the schema that they wanted or that they thought was appropriate. And then actually processing the data, that was a mess. So we're doing a very prettified version of this example. However, there's still a chance for bugs. We're going to run into them. It's just that I have a little bit of a better understanding of Python and what I'm doing. So we're going to go ahead and keep going. So we're converting to an integer, but we also want to say if, no, not strip. We want to strip that is digit and check that. So we've converted it to an integer if, and if it's successful, after we've confirmed that it's a digit, should be fine. Otherwise, return none. Great. And the next thing that we're going to do, yeah, sure, go ahead and print that. Let's go test that. Make sure we're good. Here's our first bug. See, I told you jinxed me. Okay. So now we have some information about our people. We have our first name, last name. Okay, that means that we need to skip our header because we don't need to keep header stuff. But we do want to make sure that this is right. And so far, sorry, not that one. This one is right. Great. Let's go get rid of that header. So we're going to go ahead and skip one by starting here. Oops, daisy. I know what I'm doing. There's an annoying way to do this. We're going to do a normal. But I in range. Line num. Oh, it's an iterable, isn't it? CSV file, iterate, skip first row. I can Google that. Great, that's what I forgot. I'll just skip it with next. Okay, row and leader. skip hetero. I guess I could have asked Copilot to do it, but I just don't trust it. All right, let's do that one more time. Make sure we're good. Beautiful. No more hetero. Off to a good start. Okay. Now we want to make sure that we process every family. And so right now we are not saving anything into dictionaries, but we should. And so maybe we'll have a nested dictionary. So again, thinking about that schema, we haven't done anything with file name yet. We're not getting there yet. We'll do that last probably because that's the easier one. But we know that we're going to have some kind of a dictionary. We're going to have individual. Let me just, then we're going to have individual, which is going to have our first name, last name, and age. And then we have family members. It's going to have first name, last name, age, and relation. And so to make that dictionary, we want to do something like we're going to have a list of individuals. So we're going to have an array. And then we're going to have our object, which is individual, which will have. Why are you giving? Does this make sense? First name. It's going to be a dictionary. No, I don't like that. We're going to do, that. And then we'll have the relations object, which is going to be, there we go. Okay. That's a little better. So our dictionary, our list of this will have name, age, then we have the relations, which will then have a first name, last name, age, and relation object, of which you could have multiple, and so on and so forth. So let's build that dictionary. Now that we have an idea of what is going to come up. So let's call it humans and give it an empty list. And the first thing we have in our humans dictionary is to append first name, last name, age. But you'll notice that we're missing that relations object. And that's just because we don't have it yet. So we could do this up front and then go back to the most recently added thing and add all those relations, or we could do this at the very end. So let's go ahead and move this to the bottom, where that's going to be added after we go ahead and grab all the family members. We know that this works. There's been no inconsistencies that I care to deal with. So now let's process all those family members. And we'll do something similar with that dot append to add the relations, where we're going to need to do that. Relations equal to that. And we'll fill that in by doing it here. So we know that we will always have 4 items. We will have first name, last name, age, and relation. So as far as indexing goes, it's going to be a +3. So let's make a oops, I do this all the time. Come on. There we go. So let's call it a family index. And we know that we're going to have those 3 extra fields because we have repeating groups of 4 columns. So now we want to make sure that we iterate through it. But we also know that we may or may not have a 0 to many instances or repeats of that. So with that in mind, this goes from using a for loop where we might be like, oh, everyone has a mom and a dad, or a mom and a mom, or a dad, whatever it is. But we don't know that for sure if we only ask them for living relatives, for example. And so a little too serious, sorry, but we're going to use a while loop because we can't guarantee how many family members someone's going to list. So while family index, and then we're going to add 3. We're going to make sure that we're not at the end of the row. So the row, and then we're going to go ahead and do the first name again. So we'll get the first name at that index, and the last name at that index, and the age at that index, same deal. And now we have the addition of relation. Do we need anything else? Oh, something to consider that would have introduced a bug is the fact that we're using these same first name stuff here. So maybe we call that, family first name, family last name, family age, And relation we don't need to worry about, but for consistency's sake, let's say one day we did want to say, like, what do you identify yourself as? And maybe they're like, I'm a dad, or I'm a sister, or this or that. That if we ever wanted to do that, they could do that, and we don't have to deal with conflicting variable names. Again, future proofing. And so let's go see what this prints out. So we'll go ahead and do that. Let's go test. And we get a lot of the same name. That's not good. What do you mean we get? Why are we getting this? Oh, because I forgot to increment family index. And we're going to add 4 because that's columns. Oh, you were still going. Oh, that's really awkward. Okay, we're good. But now we get some family relations. Let's go check that CSV again, though. Let's see if that actually matches what makes sense. So for the first person, they should have a cousin, a grandmother, and another grandmother, and they do. So right now this isn't super easy to parse because we haven't given any information about who that first one is. So real quick, let's go add something. Let's go make sure we know who these people are associated with. And voila. Yes, we do in fact have Aaron going ahead. Good catch. Yes, we were not. We are now. Yes, so we have Aaron who matches that first one. Then we have Abdul who has 4. 1, 2, 3, 4. Great. And now we have a few other folks. And do we have a consideration for Abraham who has no family relatives that they listed? So looking at this, so far it seems like we handle them, but I want to make sure that we actually did. And so rather than do that print, I want to make sure we did in fact capture that Abraham didn't. The fact that it skipped it, I'm like, that's great, but sanity check. I really want a sanity check to make sure that we genuinely did catch it. Okay. And it looks like there's Abraham, and it jumps right into Aubrey. I copied random names. I just went to an alphabetical list of first names and last name and copied a bunch. So we have sanity checked enough that this works. So what happens if we did add all those commas back? Just in case, you know? I'm really curious how this will purposely break this. Okay, and now we have some issues. So let's say we were working with Excel, we wouldn't have this issue, not because this library wouldn't work this way, but because there would be other issues we'd have to solve. But because we're using a CSV, and if we were downloading it from Google Drive, as I just did, let's say, you know, someone, you know, manually inserted something into the pipeline, or depending on what file format they use, they've introduced some unexpected bugs. So right off the bat, we have where some people have none. Okay, so not as ideal. Now we need to go fix this. You wanted bugs, I'm giving you bugs. I'm giving you human user error because humans suck at not creating errors. So let's fix that. So we want to check and make sure that if there is none, then don't print it. Don't do anything. We do know that someone will always give information. That is something that is guaranteed. We've asked our boss, like, yes, there will either be someone or there will not. So, as in the case of these, let's go get rid of it. Where first we can basically check and say, well, if the row at family index is not strip, I need an if statement. If equals none, print no family members, and then else process it. And we're going to leave that increment just in case. And quick check. That did not work the way I wanted it to. Did I just hit enter for no reason? No, that didn't work. Great. And it's because it's not none, but I'm pretty sure it's because it's an empty quotation. There we go. So we have no family members. Okay. So now that we've checked for empty quotations, then we want to not print anything. So instead, we will check that it is not equal to blanks, in which case, do the thing, clean up our print statements, and we're back to where we were. So now we have a check just in case someone likes to introduce issues, because otherwise our while statement will correct it for us. But if there are empty quotes, now we handle it. Awesome. So if we had just jumped straight into writing our database, we would have a lot of empty rows if our database let us, depending on how we write our conditions and our criteria. So this is also why we do testing before we add to the database, instead of just like, yes, we're good, just write, just assume it works. No. Otherwise, you have to like go delete the database, or delete the tables, and fix a bunch of stuff, and it's not fun. Okay. The point is, we have our printouts. We can now go ahead and create this object where we have relations. So we know that we can actually, oopsie daisy, move this above, and we'll leave those. We'll leave those print statements for debugging for right now. And we need to go here, and we're going to say relations.append. And it's going to be, yes, that first name, last name, age, and relation. And every time it's going to give us a new object. And rather than adding an empty brackets, we're going to add the relations object. Cool. So the last thing I want to do when we're done here is, where do I have this? Let's go ahead, when it's done with the file, print humans. I want to see what it looks like after we do our debugging. That was a disastrous idea. I should never have done that. Jesus. But we know a little bit about the first inputs, the first row of the database, which is that we have Aaron, and their last name is Abad, and that they have here's one entry for the relation, 2 entry for the relation, and 3 entry for the relation, 1 cousin, 2 grandmothers, which matches, and we don't have any extras in here. Okay, so the smart thing to do is to actually introduce new lines between like all the humans, so that way you can actually read this and make sure that things are correct. We're going to be lazy, which I would never recommend doing in the real world, and just say, yes, everything looks great, everything works fine. That's not a good idea, but we're going to do it anyway. Okay, so we have confirmed that we have processed our very strange CSV. Now we can start doing database things because we've mostly confirmed it's fine-ish. So we're going to go ahead and we're going to go create those tables. So we need to do a little bit of setup for Postgres. And so this file path is up here for now. We'll deal with that later if we have time. But we can now move on, where we're going to do this here. Set up database. Actually, let's just use normal comments. I never remember the PEP requirements. Anyway, so when you are using databases, you need to make sure that the table exists before you start writing to it. This is both common practice, and yet sometimes people just don't do it. They just assume it exists. And it's kind of like when you're working with directories or files and you just assume that directory exists. And when you go to find the path, your program yells at you because it's like, well, this directory doesn't exist. Or in my case, in Stickerbase, I deleted the uploads folder repeatedly. And so I made a condition to say, if this folder doesn't exist, please make it, because I would delete things to restart my work, because I would be like, well, I'm debugging, so I want to have a clean database that's not full of garbage. Yes, so dictionaries are basically they're like JSON objects, and that's the best way that I've understood them, is that if you're familiar with JSON, you can do Python dictionaries, and vice versa. But let's see, if you had a JSONB or JSON format for a column type, would you access it like an object to process the data? Kind of. You need to convert that string, because it would be a CSV, which means everything would be coded as a string. You'd have to do a JSON string formatter if you have confirmed that it is in fact actually going to be JSON format. So there is a way with Python that you can just say like JSON string or something like that, and you can convert things back and forth. So if you say wanted to write your dictionary as a string rather than just print it out like the object that I have, you can do that. We're not doing that for this instance, but there's a possibility that might exist for some reason. So after you've processed the string to JSON part, then you can access it like an object. But until then, not so much. Until then, it's just a string, and then you have to go parse things, and it gets gross. Cool. So basic things you'll need. We have a database name. Let's call it family. We'll just add DB for the sake of it. We're going to have the user. This is just Postgres things. Default user on Postgres is generally going to be Postgres unless you've changed it, so use the appropriate one. And because we're doing a local instance and I'm being totally safe, but this could be changed later because this might be a script in a pipeline, you might have an environments file, but for right now, we're just calling it password. I think mine is actually admin. And then our host is going to be localhost because this is going to be locally hosted. If you decided that you wanted to host this elsewhere, you can host it literally anywhere. AWS, Azure, and GCP all have PostgreSQL ability or hostability, I guess. So you are more than welcome to switch that to whatever you need. And then we need the actual SQL statements. No Copilot, you're getting ahead of yourself. We need to create the tables if they don't exist, which is create. What did we name this? We named it. I need to go find it. Let's do this and this. So create humans table. And it's going to be 3 quotation marks. Stop it. It's going to be 3 quotation marks to use this. Create table if not exists. We're going to name it capital H. I know it's a table. And yes, great. Give me a primary key. Thank you. I want this to be a short. Great. So right off the bat, we have been given some nice stuff. We have ID, which is serial primary key. This is going to be how you create a primary key in Postgres. This is their default way that they recommend rather than just ID integer. But as long as you include that primary key at the end, it will know it needs to be unique. And so maybe, heaven forbid, we wanted to make sure that the first names were always unique for some reason. We can also set up that the column itself will be unique by adding unique to it. But it doesn't make any sense to do that with humans. All right, and then we need another one for the related humans. And same thing, 3 quotations, related humans. Okay, so we have our serial primary key, we have our human ID, which is our foreign key. And so I named a foreign key here, but typically people will use the originating ID label, and that's why it's really good to sometimes have things. So you will always have an ID key generally in a table, but when you're doing your foreign key, you'll just name it whatever the reference ID is going to be. First name and last name again, age, relation, etc. And with PostgreSQL, this is how you set up a foreign key or a reference to the other table, where you're going to have your foreign key designation, your human ID, which you've already created here, and then what it references. So you need to mention the table and then, of course, the ID within it. So it's referencing ID here when you pass it into the parentheses. If for whatever reason we wanted to reference first names because they were unique, we would just replace that with first name. So that one is fairly straightforward. We don't have our files table yet, so let's go ahead and files table. Let's see, create table if it doesn't exist. Give us a serial key, give us a name. I don't care enough about pathways and whatnot. This is just an arbitrary idea. And then once again, we're going to need file ID, and it's going to be of integer. And we need to add our foreign key, file ID, references, file ID. You can see that Copilot keeps saying on delete cascade. If you're not familiar with databases, it means that if you delete something higher up on, let's say, the the priority field, where remember how I mentioned that in order for certain things to exist, the predecessor must come first. So files table must exist first. When we add a row to the files table, then we can go ahead and add a number of rows to the humans table because our foreign key now exists. If we were to do it in the reverse, it'd be very confusing. And if foreign key was required, which it is, it would be like, well, where's the foreign key that you want me to use? And because it doesn't exist, it will scream. So with that, you will need to make the files table first, then the humans table, then the related humans table. When you are populating those tables, you must populate them in the same order. Files first, then humans, then relations. Because otherwise, everything will be very upset about things not existing when you need to add them to your table. Okay, we've set up the basis for our, what's it called? Our tables, but we haven't added any restrictions in, which is that we know we are always going to have values unless some moron has created their dumb CSV that doesn't work. So let's assume perfection, perfect world, because we want to make sure that our database is clean. So to do that, we need to make sure that we add in some not null aspects to it. So let's go ahead to the human table where we will always have a not null because we have a first and last name. Not null. And this is just to ensure that there will always, I should go add on delete cascade. I should delete. Yes, this is good. This is good programming. We should do this. Yes. Okay. It's just good to have. All right. Not null. Yeah. Just wanted to make sure. There's different ways to set up tables, but this is cleanest to me, in my opinion, for readability. There is a way to just do it in one line where you have like human ID, integer, references, blah, 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 blah. I like this because it explicitly tells me what the foreign key is in my, like, I just prefer it. I like readability over, I guess, readability efficiency. I don't know. But that's more, never mind. Cool. So we have our tables. Did I miss a not null anywhere? I don't think so. We'll find out. Okay. Let's start integrating psychopg now. So we currently have this where immediately it will just open the file. That's great, but we have no way of testing this, for example, or really doing anything with it. So we would want to put this in like a function or something. We're going to start by just having a large function, not very, what's it called? It's not very readable to have a giant function, but it would future-proof or start the process to future-proof. We can refactor later. So we're now def process, insert, yeah, and we're going to pass in file path. And then let's go ahead and select all this, tab, process, insert file path. File path is defined up here for now. Great, there it is. All right, and the thing that we need now is we need to connect to psychopg. So, Copilot helping me, yay. So it gives us, with psychopg connect, which is that we want to connect to our database, and given all this information, please go ahead and do so. And it gives us this con as a cursor, which if it will, yes. Okay, so con.cursor as cur, which I think this is actually Psycup G2 information. I think Psycup G3 just automatically gives you this cursor stuff. But we're gonna let it be, and it'll probably yell at us. But now we need to go ahead and create all those tables if they don't exist, which we already have that condition in here, so we don't have to worry about if it does exist, nothing will be overwritten. All right, continuing on. Now we can do this. Let's go move that inward. Where now that this cursor is in, we need to tab that over one more time, because we want, while we have access to the cursor, to write to our database. So remember how I mentioned how everything needs to exist first? I don't have the file stuff. I'm gonna hold tight on that one. Actually, we'll delete that really quick. Comment that, and then we're gonna delete, oops. That's the foreign key stuff, and get rid of that. I think this is the way to do the foreign key stuff. Okay. All right, let's write the write to. Yes, okay. Let's do it here. So first, we're going to go ahead and insert. So we need cur.execute. This is how we do anything with PostgreSQL through psychopg. And we're going to insert into humans the first, last name, age, values. Great, thank you for that. And so this does a little bit of a formatted input, again, where we're expecting those three values in the same order. Fairly straightforward. Then we need to get the ID that came from it. So in order to do that, let's go get the human ID, which is going to be, go get the fetch one, which, let me double check on this one actually. I think, is it fetch one, or is it, there's some, I just want to get the most recent entry, which I'm pretty sure it is that, yes. So when I have done this select statement of fetch one, it will fetch the next row in the results set, return single or none when there's no more row available. How do they do it? So, okay, they do select, they get the first one, and they keep getting the next row. What if I want to get the most recent row? Python psychology. Get ID of inserted row. There we go. Okay. They did try all, current val. I want to make sure I handle, okay, it is that. It is that. Yes, we did that correctly. Okay, yes. Just wanted to make sure. Okay, so we have human ID, so that's our foreign key. And then it says for relation in relations, execute inserting into related humans the ID, the first name, last name, age, relation, and all that stuff. Great. And then let me wrap that so we can read it. So much like we would inserting things into the relations, that append here is what's going on in this current execute. Okay. So we could use the dictionary object we've created, or we could do it while we're processing it. This is, again, a processing or like a choice dependent thing where maybe you want to do it all at the end after you've processed all the data. This is one way that you might be able to test things before you write to the database and handle anything. On the other hand, it does mean that you spend time, like if you separate the processing and then the insertion bit, which means now you have completely separate functions that you could create, and you can uncouple those. But if you merge them together, then you have your one long bloated function. So for now, we're going to actually leave this at the end for the sake of future proofing, where we would refactor into multiple functions to do specific things. And then the last thing we must do, I'm trying to find the end of it, is I believe we need to close the connection, but I think we also need to finish something. Let me go ahead and open. Nope. I wanted this. I actually have basic module. Yeah, here we go. Okay, yes. So I have the library up because I was using this as reference. But they have connect as connection with cursor as cur, which is what we did. We have creating a new table. They've executed stuff. Then they've queried to get different information. And then they make the changes persistent using con document. Okay, that's what I was missing. Okay, I'm pretty sure this will fail because I don't have a running database instance and it doesn't have the port number that it needs. Yes, so it has failed to connect because it's using the wrong port because I messed up my settings. I need to change G3, change localhost port. I don't want to do that. I want to do this in... Okay, that's just a port. Great. Port, because the default is going to be 5432, but I have it on a 5433 port, and I need to go add that. Pretty sure because it's not running, it's going to yell at me anyway. So port, I can spell today, which I cannot. Port, and I'm missing a T there. And I didn't name this correctly. That should be DB port. DB port. Oh, you're yelling at me because I put a dot instead of a comma. Okay. Try that now. I'm expecting that one to break as well. Yes. Failed authentication for user Postgres. Here we go again. Maybe I didn't do that. FamilyDB does not exist. Yeah, because I want you to make it. Oh, I forgot to make the database. Let's go open pgadmin really quick. Okay, may as well show you pgadmin while we're at it. Ooh, pgadmin 4 got fancy. I had version 10. I think they're on 14 or 17 right now. So I upgraded last night. And I'm like, I wonder how much it's changed. Given it's taking forever to load, it probably has changed quite a bit. Come on. You can load. Or don't. I mean, take up the whole stream time. Come on. You'll load, right? Right? Please? I should have uninstalled PG stuff before I installed. So the internet loves pgadmin 3, apparently, and they hate pgadmin 4, which I'm like, but I only ever used pgadmin 4, and I thought it was great. Oh, it's just like straight up not loading. Come on. You can do it. It's just... watch it not load. Okay. Pretty sure I can create a database. We'll just create the database. pgadmin is not loading. I have no idea why. Oh, task manager, come on. Well, I have 2 running now. I only want 1. We'll just end the task entirely and try again. Why are there 5 processes? I shouldn't have upgraded that. Oh well, let's go create the database. We'll just do it that way, since it refuses to start. FamilyDB does not exist. Well, what did I say the password was? Postgres? Yes, I'm aware. Come on. There's also a shell that comes with it. Create database. This isn't gonna work. Actually, no, we can change it. We'll just do it this. Okay, I can at least log in. That's good. Let's change this to Postgres. And we're gonna comment this out. I think it's because my instances are broken because I need to uninstall and do some more stuff. So we're gonna comment this out and try again. Hey, now we're getting issues. I much prefer this. Oh, syntax errors. I should have read that. Create human state. Okay, I didn't like here. But there should be parentheses here. Yeah. Oh. Short does not exist. Rude. PostgreSQL types small. Is it small int? Numeric types small int. What if I want a really small integer? Small int. All right, we'll just swap that and change age to that. Now we're debugging. All right. Error at the end of the input. Thank you. Okay. The last operation, this is what I expect. This is what I did want to deal with. Okay. Oh, PG admin 4 could not be contacted. Oh, because you think you're supposed to be there. No, honey. You're in... I need to fix paths for that. Configure. I need to reinstall that. That's fine. That's an I goofed. I was supposed to. No, I'm pretty sure I solved that elsewhere. Okay, well. It probably does, but SQL and PostgreSQL keywords are different. As you saw, this let me write short without issue, which I hate. I prefer typing them out because then I at least have a better idea of what my tables look like. And they're like, I'm able to like debug them a little easier. Like, yes, I've designed them, but this is more to like visualize it that I care about rather than actually typing it out myself, because depending on the database that you use will determine the keywords that are effective. Also, I just don't want to pay for shit. Let me see if you're right though. Yeah, I don't see anything immediately about Oh, yeah, I can import or export. Yeah, no, I have to sign in. No, thank you. No, thank you. Anyway, we have our database created actually though, because it exists there, right here. Yeah. So the issue we're having now is that the operation didn't produce a result, which is down here in this fetch one. And I think, what was it? We'll just go Google that actually. Scikit-G did not produce an error. Tell me why. Second way obtains the ID field. Returning ID. Let's double check. Let me double check. Scikit-G return ID. Well, let's just use it. Let's see what happens. Returning ID. Hey, now we made it to the end of our script. Now, let's go check this. So I don't know if I can, yeah, I can't zoom in on this, but let's go double check that things exist. So let's select, it was family EB. Did I name it? I never remember what I named it. We named it Postgres. Then we created select from tables. Select humans table from, actually, just, there's a way to list tables. Oh. There we go, /Z. We now have a public humans, public ID sequence. That's just to create the IDs. We have related humans. Awesome. And then let's see what comes up. Come on. I'm forgetting how to grab this. One moment. Oh. Now you want this. Not select star. Fine. You should be fine. What do you mean? What do you mean? So, because I don't use PSQL that much. You know what? Okay, well now we have IDs. Great. We'll just do it manually. It's smarter to do that anyway. We called it first name, last name, age. There we go. Now we've got everybody. Hooray. It's because I forgot quotes. Curious. What do you mean? Oh, it's because I had incomplete commands. Duh. Anyway, we now have our process CSV. We have our various relations. Let's go get, is it related humans? Hey, that looks really nice and pretty. This is not visible. Like I'm like leaning in to read this. But the point is, we have our tables. Thank God. We did not finish on a bug. Hooray. Okay. So, walking back what we just did. We processed our CSV of data. We handled some weird cases where humans introduce annoying bugs. And then we use scicopg to create our tables and also to write to them, get that ID, and write other nested things. Fantastic. And we finished with plenty of time to spare. So if there are questions related to this project or to what we went over, I mean, please go ahead and ask. But otherwise, you're free to go. Although, let me tell you what's coming up next. Next up, literally right after this, actually, so you get potentially like a 20-ish, 30-ish minute break to go eat, take a break, take a walk, grab water, all that stuff. Alberto is coming up next with his neural networks using MATLAB Part 2. So if you didn't get a chance, then what a great opportunity to go watch his past stream, his Part 1. That can be found on YouTube. So that way you can make sure that you're ready to go with his stream coming up. And then, is there anything else? I think as for what streams are coming up next for me, there is one more stream that I have that I'm hosting. That's tomorrow. And as far as technical content goes, and that will be a GitHub overview. So if you aren't familiar with GitHub in the command line, we'll be going over all sorts of things and also exposing you to some of the lesser used but very important commands, such as things like cherry picking, rebasing, etc. Cool. Any other questions? Ooh, I realized I wasn't very zoomed in, so I hope people could read this. I get the funny feeling maybe not. Awkward. I usually try to make sure I'm zoomed in enough that people can read, but I forgot to check that this time around. RIP. I'm sorry, folks. I'm going to give it till 5 after the half hour to ask any questions. I can keep working on my very large sweater for my partner that I have to finish before Christmas. Because it'd be really awkward if I lost. No, yes, that's right. I was halfway with that sleeve. Thanks so much for coming. I'm so glad that you've been able to hang out this week. Giving it a couple minutes in case anyone's got a question. On the other hand, this was supposed to be a very easy stream to just get people thinking about databases or thinking about how they'll design their databases, especially when given strange files that they have to process. As a side note, I apparently have 90 rows to do for this sleeve, and I'm just like, oh, that's going to take forever. Hence why I'm waiting for questions and working on the sleeve. All right, we're at the 30-minute mark. Not seeing any questions, so yeah, like I said, I'll give you back your time and hope you enjoy the rest of the day or evening, and thanks for coming. Again, this was supposed to be an easy stream to get you thinking about database design and scripting, and how you'll process data in ways that hopefully don't mess up your original data form. Yeah. Cool. Have a good one, folks. Thanks again for joining, and see you tomorrow at, I think today in Global Hack Week, and for the last GitHub stream. Yeah.